I guess we're good to go. Good morning, Dylan, or yeah, well, good morning for you, I guess.
It is. Good morning for me, and what a dobry dan for you over there in Kiev, Alex. How you doing?
Yeah, it's so welcome to the .NET fwdays conference. You were here 2 years ago, I guess, in
I
person, but you
was.
couldn't make it. You couldn't make it this year, so you went through a lot of trouble to be here online. Can you tell us a bit about what you did?
I'm actually, yeah, I'm on holiday at the moment at my parents' house on the south coast of England. So I had to, the fwdays were like, hey, can you talk at us? I'm like on holiday. They're like, oh, please. I'm like, all right. So I've had to bring like cameras and laptops and all this stuff with me and build this little studio, which you'll see. I got a slide in the talk where I show you the setup that I'm using to present here. But it's interesting because I do think, a lot of as we start, in-person events start happening, but there's going to be different countries that have different restrictions and all that kind of stuff, and there's still going to be a lot of online events. I think a lot of our speakers are going to be doing online talks when we're not at home. I think we're going to be traveling, and so we're going to have to work out how to do like online talks from a hotel room or something. So this is like my first production test of all this equipment and this setup. So hopefully it's all going to go beautifully smoothly.
Yes, and hopefully next time you'll be here in person and maybe do a bit of a performance on the after party.
Oh, I can't wait. I'll be back as soon as I can.
Yeah. And now you're going to show us about there's no such thing as plain text.
That's absolutely right.
Yeah, so let's not waste any more time. Go ahead and take it away to show us what that's all about. And have
Fantastic.
fun, Dylan.
Thank you, Alex. And hello, everyone. And yes, I'm going to talk to you about plain text, because we're developers, and we think that we know about plain text, but actually, turns out, does plain text even exist? Is there such a thing? That's what we're going to talk about for the next half hour. So this is me. Some of you have seen me at various online, offline events in Ukraine and over the internet and stuff. I'm Dylan Beattie. I run a company called Untitled, which does online training and workshops. So if you want to learn stuff about .NET and JavaScript and distributed systems, and you want to do it all online over Zoom, check that out. Be really happy to talk to you. I'm a Microsoft MVP with the Developer Technologies program. I run a .NET user group here in London. And some of you may know the probably most successful thing I ever did was actually a joke that turned into a joke that's now an actual programming language. That's still a joke, which is the Rockstar programming language. So if you ever want to look through LinkedIn and you see all those adverts wanting a Rockstar developer, you can be a Rockstar developer. Go to codewithrockstar.com and learn the language, and there you go. And like I said to Alex at the beginning, I'm actually away from home right now. I am here. This is the view from just outside of my window there, and this is the view from just inside my window here. This is my little portable remote presentation setup. It should all be fine. Everything's been tested, but if anything does go a little bit weird, then that's why. It's because I'm running all this with a bunch of laptops and iPads all wired together with USB cables and stuff. So if I drop out, don't panic. Alex will tell jokes until we get me back on the call. And yeah, I'm going to talk to you about plain text. And when I, first started putting this talk together, people were like, really? You can do a conference talk about plain text? Like, what is there to talk about? Well, there's a lot of stuff to talk about. Now, the basic principle, the thing that makes technology and software and the internet, the thing that makes all this stuff useful is that a human being, we can have an idea, or we can have something, a concept or a piece of music, a picture, something like that. And we can take that thing that exists out there in the real world and exists in our heads, and we can turn that into data. And we can use technology to process the data. We can transmit it, we can convert it, we can search for it. And then when it comes out the other end, we can decode it, and somebody else can share that same idea that we had in the first place. And we've worked out how to do this with a whole bunch of different kinds of data, but one of the most common and significant ones is text. How do we get text into a computer and back out the other end? And the talk today, this kind of starts in the 1960s. With something I'm sure all of you have heard of, which is Ascii, the American Standard Code for Information Interchange. Now, you ask developers, hey, what do you think about Ascii? It's like saying to a fish, hey, what do you think about water? And fish is like, well, it's just everywhere. Why would I have an opinion about that? Because it's so ubiquitous. But there's a lot of interesting stuff in Ascii that as we unpack it, we learn about the decisions and the hardware and the history of a lot of stuff that is still things that we work with today. Now, thing about Ascii you got to remember is it was it was ratified in 1965, the first version. The one that we still use today was actually ratified in 1968. So it's over 50 years old. And it was designed to work on computers like this: mechanical teleprinters, teletypewriters, and punch card machines. Now, if you have a look at the Ascii character set, if you look at that bottom block, the first 32 characters of Ascii. We start with the null, all the zeros, which is familiar to anyone who's ever worked with C or C++, because those languages used, and some of them still use, that means the end of a string. And if you've ever seen a buffer overflow errors, a lot of them are because of problems to do with null. But then the rest of this block is things that kind of maybe don't make a lot of sense, like, start of heading, start of text. Now you're thinking, well, what do these matter today? Well, start of heading, start of text, they don't matter very much. But if you've ever had one of your .NET programs go into an infinite loop and you hit Control-C on the keyboard to break out of that loop, Control-C is the ASCII character with the control code 3. And they had the convention that if you want to do a ASCII code 1, that's Control-A. ASCII code 2 is Control-B. ASCII code 3, end of text, that's Control-C. We still use that one today. That one has kind of survived. And then there's this whole bunch of other control characters: end of transmission, inquiry, acknowledgement. We don't use those very much. Bell is interesting. If you're on a Windows machine right now, open up a terminal, type echo space, press Control-G. When you press enter, your Windows computer will go ping, because that's the control code that rings the bell, which used to be a physical bell, a metal bell on these teletypewriters. And then we get to backspace. That's Control-H. Backspace key on your keyboard ever breaks, you can do backspaces by pressing Control-H. I bet you didn't know that. And then we get into horizontal tabs and line feeds and form feeds and carriage returns. Now, the thing you got to realize about line feed and carriage return: mechanical teleprinters, they had a thing called a carriage. And as you typed a line of text, the carriage would move across the screen. And then when you got to the end, you needed to return the carriage to the beginning of the line. Now, these things were really, primitive in terms of text formatting. The only way to do things like bold was to print a line of text and then return to the beginning of the line, carriage return, and then print the same line again, and it wouldn't quite line up, and so you'd get this bold kind of overprinted effect. And then you return to the start of the line with a carriage return, and then you feed the paper one line through. That's a line feed. So you got a line feed, you got another line feed. And so carriage returns made sense. It was a control system that actually got used on its own. And now we have this kind of, ongoing controversy about carriage returns and line feeds. If you're on a Linux machine or a Mac OS machine, something which has a Unix-style kernel, you're like, hey, /n, that's the end of a line. If you're on a Windows machine, it's /r/n, carriage return new line. And the reason for this goes all the way back to the 1970s, because Unix evolved out of, or rather, modern OS is Linux and Mac OS, they evolved out of Unix, and Unix evolved out of a system called Multics. And Multics was the first operating system in history that had device drivers. It actually had some software that sat between the operating system and the physical hardware. And that meant that there was a place where they could put in some code that said, look, if they send a new line, return the carriage as well, because you're never going to do a new line without going back to the start of the next line. So they had an abstraction layer. But Windows 10 evolved out of Windows 8, which evolved out of Windows 7, which evolved out of Vista, all the way back to Windows 3.1, to MS-DOS, to CP/M, and CP/M evolved from a system that was designed to run on really cheap mini computers, and they didn't have device drivers. So if you wanted your teleprinter to go to the start of the next line, you needed to do a carriage return and a line feed. And that was the decision that got baked into version 1 of CP/M, and it's a decision that we are still supporting today. Now, if you're on .NET, of course, it doesn't matter. We have environment new line, cross-platform abstraction over these two things. Let's look at the next chunk of ASCII. Now, we got a bunch of punctuation characters in here, exclamation mark, double quotes. One of the interesting things about ASCII is that when it was put together, which was in the United States in the 1960s, they kind of looked at all the characters which were being used in print, in books and newspapers, and they didn't quite have enough space for all of them. So ASCII, for example, ASCII number 45 is the hyphen, this little horizontal line. There's actually 4 different kinds of horizontal line that are used in typesetting. There's the hyphen, there's a dash, there's an M, or there's an M dash, there's an N dash, and there's a minus sign. And in professional typesetting, they're all different. In Ascii, they're all the same. But now that we've got e-readers and high definition retina displays and stuff, a lot of those characters that kind of got dropped along the way for a long time, we're starting to use those again. And you're starting to see those being used in ebooks and that kind of thing again. And then we get to the digits. Now, one of the things that you have to do a lot with computers is turn numbers into strings and turn strings back into numbers. And the way they designed the Ascii table, you could do this with the digits just by ignoring the 4 greatest bits. The Ascii code for 0 is the number 0 with a bit of padding on the top of it. So you could do these using 4-bit bitwise operations, which were really fast, even way back in the 1960s and 70s. So you want to convert ints to strings and strings to ints. All you need to do is ignore that top half or just do a bitwise AND and stick the top half back on there. There's a couple of other optimizations in this next block here. You want to do a case insensitive comparison with Ascii. The difference between a big A and a little a is 1 bit. You just ignore the 6th bit of the Ascii set, and you've got a case insensitive string comparison. And finally, at the end, we have the Ascii delete character, 127, which is a block of 1s. All the 1s. You know why Ascii delete is all the 1s? Think about a punch card. Think about a piece of cardboard with holes that have been punched through it to store data. You can't fill the holes back in. Like, you can't erase that. The only way to remove data from a punch card is to punch through all the other holes as well, so you end up with what they call a confetti card, which is just all the holes. And that's why the delete character is that, because if you print a delete character onto a punch card, it punches all the holes out. You can no longer read what was on there before. So the American Standards Association, which became ANSI later, they pat themselves on the back and they're like, we solved it. We got 127 characters. That's all you're ever going to need. And the rest of the world goes, hang on a second, what? We can't work with this. Now, for some cultures, you know, Western European, Scandinavia, there were just a couple of things missing. For other cultures, Ukraine, Russia, Korea, Arabic, Hebrew, they're like, we can't even begin to work with this. Like, you literally have none of the stuff here that we need for our for our alphabet. So we had a problem. Now, I first encountered this problem when I was a kid growing up. I grew up in Zimbabwe, where they speak English and use dollars and cents. And so we're kind of culturally compatible with what was going on in the United States. I just need to adjust something here. Give me 1 second. That can go down to there. All right. And so, sorry, yeah. I grew up in Zimbabwe. Dollars, cents, English. It wasn't really a big problem. When I moved to the United Kingdom when I was about 10 years old, I wanted to print this. I wanted to print a pound sign that I'd used in my homework. And I couldn't, because my computer, my MS-DOS computer and my Epson.matrix printer, they did not speak the same language. And this pound sign was not included in Ascii. Now, a bunch of people all over the world, they looked at this Ascii character table and they're like, well, hang on, we've got 8 bits here and Ascii's only using 7 of them. Is anyone using this bit? Can we use this? And it turned out it was up for grabs. So lots of different people and companies and standards organizations, they all jumped in and went, right, we got a brilliant idea. We're going to use the top half of Ascii to solve our problem. Now, this is what became known as code pages. A code page is a rule that says, look, the top half of the Ascii 8-bit character set, in this code page, it looks like this. And there's code pages for Greek and Russian and Ukrainian and Korean. And it gets more complicated than that, because there's like an IBM code page for Greek, but there's also an Apple code page for Greek, and then there's also a Windows code page for Greek. One of the most famous code pages is this one. It's code page 437. It shipped with the IBM PC, and it included a whole bunch of characters for drawing lines and boxes. So you could build these little text mode, menus and windowing systems. They also went, we're not using teleprinters anymore. We can reuse the bottom block for playing card characters and little, kind of ASCII art style signs. Now, if you've ever seen an IBM PC crash really, really hard, it fills the screen up with this kind of nonsense, and that's why. These are random control codes being interpreted through code page 437, so you get a screen full of playing cards and smiley faces just before you have to turn the power off and reboot your IBM PC. Now, this is a little screenshot from part of the Wikipedia page about code pages. There's a lot of these things, like loads of them. You wouldn't believe how many. This was a problem. And it became a massive problem when we invented the World Wide Web. We started connecting computers to each other and we were sharing information. And suddenly people were like, well, I need to write an email which has like some Russian and some Hebrew in it. How do I do that? I'm like, oh, sorry, you can't. You've got to pick one language. That's all you're allowed, because you couldn't mix code pages. We needed a better system, and that is where the Unicode Consortium came from. Now, the mission statement of the Unicode Consortium just says this: to provide a single, consistent way to represent each letter and symbol needed for all languages across all computers and devices. Now, that's a kind of big deal, you know, to a single consistent way to represent each letter and symbol needed for all human languages, all computers, all devices. And the amazing thing is they actually did it. And we're going to look at some of the problems they had to solve. So first of all, you know, take a look at these two strings, these two pieces of text. Are these the same? They look the same, right? They're not the same. One of these is Horosho, Russian. The other one is exoplanet, which is an English word. So the Unicode Consortium, they had to decide, well, are these, they're the same shape, but they have a different sound. Are they the same letter of the same alphabet or not? You get things like these. This is tiger and tiger. Same word, kind of, it means the same thing, different languages, different alphabets. Is that T the same letter, or is it a different letter? They decided it's a different letter. That a Cyrillic T and a Latin alphabet T, even though they're the same shape and they mean the same sounds, they come from a different cultural context, and so they are different letters. Now, I'm British English, so when I travel around and I see words written down like this, what my brain does is it goes, yeah, I can read that. I mean, I'll ignore those parts because I don't know what those parts mean, and I'll just read what's left. And so I'll walk into a hotel in Norway and I'll say, can I have a half-owner? And they'll roll around laughing because that's not how you pronounce it. I think it's a half-owner, which is the Norwegian word for a hairdryer. Now, like I said, I ignore these little accents because in British English, we don't have them. Those don't appear as part of our alphabet. So the question is, you know, are they important? Do they matter? And that depends on your culture and your context. Let's meet some friends of mine. This is Francois Baudin, who's a French archaeologist, and this is the rock band Motley Crue. And I'm going to write down this sentence. I'm going to say, Francois the archaeologist went to the Motley Crue concert. Now, this is English. This is an English sentence, but there are characters in this that are not part of the English alphabet. We got the C with a cedilla. That's an English loan character from French. We've got the AE, which is an old-fashioned way of setting certain kinds of words. And then we've got the O and the U, which have the umlaut over them. Now, the first time Motley Crue toured in Germany, the audience were all shouting Mötley Crüe, because that's how you pronounce those letters. And the band are like, why don't they know our name? It's like, because you can't spell your own name. And in Hollywood, that doesn't matter. Now, making Motley Crue look stupid, no big deal. That's easy. But sometimes these kind of things can have real consequences. Some of you may know this guy. This is Magnus. It's not actually Magnus Mårtensson. This is Magnus Mårtensson. He's a Swedish Microsoft Azure MVP, does a whole bunch of .NET conferences and community stuff. And a couple of years back, Magnus is traveling to the United States. And he arrives at US passport control. Now, Magnus has a Swedish passport. And all passports have this little strip at the bottom, which has to be machine readable, right? And that's the rules of how you make passports. And the Swedish government says if you have the O sound, which is the A with a little circle, that converts into AA. And the people who'd printed Magnus' airline ticket, they didn't care what the Swedish government thought. They're an American airline. They just took the little circle off. So Magnus gets to US passport control with a passport that doesn't exactly match the name on his ticket. He got asked some complicated questions. Eventually, they let him in. But, you know, he's a well-dressed white guy. He's articulate. He's on his way to a software conference. He's talking about Microsoft and things. Think about people you may know who might have had a much worse day if they had arrived at the US border and tried to get in with an airline ticket that did not match the name on their passport. And all because we can't decide whether this is a letter of the alphabet or it's two letters combined into one or what. We can't decide how to translate between these things. It gets even more complicated. This is C with a cedilla on it. Now, there are lots of different ways of setting this. In the French alphabet, this is a letter. It has its own code point in Unicode. It's just a thing. But when we set this in English, we use the English letter C, which goes all the way back to Ascii, and then we put this thing on it, a Unicode combining diaresis 0327. Sorry, a combining cedilla. Now, the great thing about these combining characters, you can draw them on anything. You can say, whatever you just drew, add one of these to it. And you can stack these things. And if you've ever been onto Stack Overflow and looked for why you shouldn't use HTML to regular expressions to parse HTML, and you've got the famous thing about Tony the Pony, that is Zalgo text, and that is made up out of this. It's combining characters being applied multiple times to the same letter. That's how we get Zalgo. Now take a look at this, Dobry Dan. Now there are two different ways we can set the word Dobry in Unicode. We could write it this way, or we can write it this way. We can have it as 6 characters, or we can have it as 6 characters plus a combining accent character at the end. Are these the same string? Now, if you do a binary code point comparison, they're not. But they look the same, and they sound the same, and we read them the same. So are they the same? .NET and Unicode, they don't make that decision for us. What they do is they give us a set of tools that we can use in our own software to say, this is how we want to solve this kind of problem. And these are known as normalization forms. Now, there are 4 different ways of normalizing text in Unicode. There's a C and D. C stands for composed. Squish this down into the smallest number of code points. Decomposed means stretch this out into the largest number of code points. And then the K stands for canonical, because C had already got used for composition. And the canonical means don't worry about what it looks like, worry about what it means. Now, if we take a piece of text like this, Motley Crue, and we got 2 different ways here of creating Motley Crue. One is to just put the Unicode characters in, the other one is to use a combining diaresis. We're going to stick those together, and then we're going to do different string comparisons on those 2 bits of text. And when we run them, is string 1 equal to string 2? Well, a binary comparison says no, but under all 4 normalization forms, these 2 strings are equivalent. Now, there are other sets of characters in Unicode. We've got these. We got little letters in circles and those kinds of things, which you see some people use in Twitter profiles. If we do the same comparison there, and we compare these, now you'll notice the font I'm using on my console can't actually print the capital letters in the circles. It's one of the problems you find with Unicode, is lots of fonts and typefaces, they don't have all the letters because they never got around to adding all of the letters. So you get a little box with a question mark in it. And so here we've got these 2 strings. They're not binary identical. They are not composition identical, but if we say, look at the canonical form, do these, like, would an English speaker think these are the same string? You'd look at it, you're like, well, yeah, it says plain text, you know? Now, encoding the characters is only half the problem. The other problem you get is, how do you then turn this stuff into bits, and how do you store those bits as bytes? And a couple of years ago, I was at work one morning, and someone came over to my desk, one of my team, and I said, dude, I think we've been hacked. Now, when you work in software, you get this all the time. I think I've been hacked. No, you haven't. You've revealed codes. You shouldn't have pasted the JavaScript that someone sent you on Telegram, all this kind of stuff. But the person who said it on this morning, they were a very good network engineer. And I was like, why do you think we've been hacked? There's Chinese in the Windows event logs. And I had a look, and sure enough, there was Chinese in the Windows event logs. Now, we're an English company based in London. Most of our customers are from Western Europe. Chinese has no business being in our event logs. We don't speak Chinese. We have no Chinese customers. As far as I'm aware, we are not running any software that uses Chinese characters. So we start digging, and I say to the team, you know, one of them, I'm like, you go and check the firewall logs, see if we got any trace of it. You go and search the database, see if we can find these characters in any of our records or anything. You let the team know that we're investigating this incident. And the nice thing about managing a good team is once you've given everyone something to do, you kind of don't have anything to do until something else goes wrong. And so I went on Twitter, and I said, it's going to be one of those days. And I love Twitter because immediately I got replies from 2 people going, hey, that looks like a Unicode mapping error. UTF-8 being treated as UTF-16 and UTF-16LE. And I thought, oh, yeah. I don't know what any of these things mean. So I had the fastest crash course in how Unicode and Windows string encoding works. And basically I dived in. I'm like, what is going on here? And what I learned that morning, Windows and JavaScript and .NET and Java, a whole bunch of other languages, internally, they store every character as 2 bytes. They use a thing called UTF-16. The reason they do this is so all the characters are the same width. Memory is cheap and performance is important, and this means it's really easy to do things like get the lengths of strings. So that word delete in Windows internally is this sequence of bytes. Now, if those get swapped around so that we get the big N first instead of the little n first, we end up with this. And when you turn that back, you get the exact Chinese that was showing up in our event logs. This is the word delete that had been scrambled. So the next question is, well, why are the Windows event logs being swapped from big endian to little endian? Turned out they weren't being swapped. Turned out what was happening, we had a faulty network switch in one of our virtual networks that was dropping 1 byte occasionally. Just 1 byte was going missing. And so everything else in that byte stream was getting moved sideways. And when that happens, it doesn't know where the byte boundaries are anymore. And so the system goes, all right, well, I guess this must be Chinese characters. Now, big deal, all right? The problem with UTF-16, you don't know where the boundaries are. That D or the Chinese characters, those things are identical. There's no way the operating system knows which one is correct. Now, one of the other problems with UTF-16 is when you get to sending information over the wire, over the internet, it's not very efficient. Even if, so we got a little web page here that says Privyet in Ukrainian, but even if your web page is in Ukrainian, all your HTML, CSS, your JavaScript, all that kind of stuff is in Ascii, because we use Ascii as the basis for most of our programming languages and platforms and environments. And so we've got this much text actually needs to be in Unicode, and all the rest of it, if it's in UTF-16, it's full of zeros. Every one of those UTF-16 code pairs is a 0, 0, and then a something, and then a null, and then a something, null, and then something, which means this about 44% of the data here, that's redundant. We don't need it. And if you're using UTF-16, you have to transmit all the zeros every time because that's how the encoding works. And so the Unicode consortium are like, we got to be able to come up with a more efficient way of managing this kind of stuff. And they come up with something I think is brilliant, which is UTF-8. Now, the way UTF-8 works, any byte, you look at a byte, if it starts with a 0, then that byte is part of, same as Ascii, hasn't changed. Anything starting with a 0, the other 7 bits are the same as they were in the Ascii character encoding way back in the 1960s. Anything starting with a 1, that's part of a multi-byte sequence. And if you don't know where you are, if you don't know whether you're looking at delete or you're looking at Chinese, what you got to do is look for something that starts with 2 1s. And if it's a 1 1, then that means this is the start of a 2-byte sequence. Anything with a 1 0, you've just landed in the middle of a character. You need to back up a little bit and find the beginning, and then you can figure out what character this is. So if it's a 1 1 0, that's a 2-point encoding. 1 1 1 0, that's a 3-byte encoding. 1 1 1 1 0, that's a 4-byte encoding. It stops here so that we can round trip from this to a thing called UTF-32 and back again. In theory, you could go up to 1 1 1 1 1. You could have like an 8-byte encoding using UTF-8. It's that scalable, which is going to come in handy when we have to encode all the languages and alphabets used by all the alien civilizations that we eventually make contact with. But I think that's brilliant, and I want to leave you today with a little observation about something. When I was first visited Ukraine a few years ago, I was going around. I stayed at the Premier Hotel Rus and went to Docker's Art Pub, and I had an absolute blast. At this point, I'd never learned the Cyrillic alphabet. I didn't speak any Ukrainian, speak any Russian, so I'm wandering around. I can't read anything, except I realized I can read the license plates on the cars. And I thought, why in Ukraine, why in Kiev, do the cars use English letters on the license plate when everything else is in Ukrainian Cyrillic? And I did a bit of digging, and I found out all sorts of interesting details about the history of vehicle license plates. And way back in, the 60s and 70s, actually the same year they signed off Ascii, they signed a thing called the Vienna Convention on Road Traffic, which the Soviet Union was one of the signatories to that. And it had this rule that says, if you're going to drive your car internationally, your license plate has to only use Latin letters. And the Soviet Union went, yeah, no problem. And they signed it, even though their license plates looked like this. And someone was like, why is this a problem? And they said, you can't drive your car internationally from the Soviet Union. We're not going to let you do that. But then when, Ukraine and Belarus and all of the other countries, gained independence in the 90s, they all overhauled the way their vehicle registration works. And now those license plates look like that. Russia did the same thing. And I did a bit of digging. This is what I discovered, is if you take the Cyrillic alphabet and you take the Latin alphabet and you look at the shapes, they're not necessarily letters, but they're the same shape that occur in both of those alphabets, you get this set of characters here. And that is the set of characters that are used on vehicle registration plates in Ukraine and Belarus today. And it so happens that if you shuffle those letters around a little bit, you get this English phrase, you get pike matchbox. So next time somebody says to you, hey, I'm going to send you a plain text file, you say to them, hey, do you know about Pike Matchbox? And if they say, yeah, then it means they've seen this talk, and they know about Ascii, and they know about Unicode, and they know about code points, and that's fine because they're going to tell you what they mean when they say plain text. And if they say, what's Pike Matchbox, then hang on to your hat because you have no idea what kind of file they are going to send you. The only thing you know is they said plain text, which means they can open it. It works on their machine. What happens when it gets out onto the internet? We don't know. That's anybody's problem. Thank you very much for listening this morning, fwdays. I hope very much to join you all in Kiev in person next time around, so we can talk about code and technology and share ideas and have a bunch of fun and go to Docker's Art Pub and have some vodka and chicken wings. But for now, I think we have a bit of Q&A coming up. Thank you for tuning in. And if we have some, Alex, are you on the line there?
Yes, we are.
Right.
Hi, Dylan.
Hey, how you doing?
Talk again. Thanks for sharing.
Thank you.
Yeah. I'll never look at plain text the same way again. Yeah.
It's surprising how much stuff in technology. The reason I enjoy digging into the details, these kinds of things, is because it's, you know, it's not knowledge that you use a lot, but the world kind of makes more sense if you know how it ended up this way. Because there's a, you know, when I first learned Control-C, I'm like, why Control-C? Like, why is it not Control-S for stop or Control-B for break and Control-C? And all right, it's Control-C. I guess that's just how it works now. And then you dig and you're like, all right, that actually, it doesn't make sense anymore, but it did make sense when they started. And it kind of just, it feels less like you're just working to an arbitrary set of rules that someone made up.
Yeah. Well, it's good finding out that there's a whole world behind the things that we take for granted now. And I guess this is happening more and more. It's the same as with the save icon, where that came from originally, the flop disk. It's fading away slowly in history. I think we do have some questions. I have Alexei here with me, and he'll help out with some of the questions that came in through the chat and Discord.
Yeah, there looks like there are no questions so far. So if you have any questions, please ask them in Discord or in Telegram chat. You can also ask them in Ukrainian, and we'll be able to translate it for Dylan. I see somebody's typing already, but no questions so far.
Okay, and then I'll have a question for you that's kind of off topic, Dylan. But
okay.
We saw you at the after party here in Kyiv 2 years ago, and you have all these amazing songs that you created as parodies of other songs and addressing things like we'll build a new framework because the one that's there is not good enough. So while questions are coming in, have you been working on a new song or new thing that we haven't seen live yet?
I have. So I have a couple of new things. The one that just went live, if you go and have a look on my YouTube channel, it's called Teams. And it's about Microsoft Teams and the whole kind of online video platforms and all the virtual meetings and all this kind of stuff. But it's got a special mention for Microsoft Teams. I've had some interesting... I've had some conferences that they use Teams for it, and eventually they had to give me an email address at their company because that was the only way they could get me to log into their organization.
Oh, okay. Yeah.
They have. I've talked to the people who work on it at Microsoft, and they're like, yeah, we know we kind of never designed it to be for conferences, and we fixed all this stuff now. So definitely, you know, it's a very interesting product, and it's one that is innovating at a great rate at the moment. But a lot of people have had some sort of fairly challenging experiences with it over the last year or so.
And which song did you use as a basis?
Steam by Peter Gabriel, which is a fun song, and I can't wait to get up on a stage with the band and actually do that one for real again.
So I'll have a look here at Alexei again, and did we get any questions?
No questions so far, but one person said that, well, they mentioned that they bought their first car in Ukraine about a month ago, but they still don't know how to read the license plate properly, whether they should do it in Latin or Cyrillic.
I mean, it's an interesting, you know, if you imagine you stole a car in Lvov and drove it across the border into Warsaw, and the police were trying to fill it in, which alphabet would they use handwriting on the form? You know, could you get stolen cars just by taking them across the border to where they use a different alphabet encoding? Because I think, is it Bulgaria also uses Cyrillic, but then Romania uses Latin alphabet. So, and, you know, I sometimes wonder if there's, you know, you get all these different database encodings. I wonder if there should be a license plate collation which is just like, we don't care what it sounds like, we just report based on the shape of the letter. Is this the same stolen car or not? So, I don't know. Either it's not a real problem, or the people who are stealing cars and taking them across the border are very, very keen that no one else figures out what they're doing. So maybe I'll leave that one alone.
Yeah, still no other questions so far. Again, just a reminder, if you have any questions for Dylan, you can ask them in Discord or in the Telegram channel. And even if you don't get to ask them now, he'll most likely be able to answer them during the day too.
Yes. I'm going to jump over. We got a Discord running. I'm going to jump over there in a minute and join the voice chat in case anyone wants to hang out for a couple of minutes and say hello. So what else is happening there at fwdays on site in Kiev?
Yeah, okay, so let me run that by you, because you've been here, so you can understand what the Kiev Conference Center at Mercure is.
Yeah.
There's still two tracks running side by side. There's the room A, which has the offline speaker there, doing a presentation like we know and love. And you were actually in another room. There was a full room for you, live, an audience with a big screen at the front and at the excuse me, at the sides of the room, and we were all watching you from there. I tweeted about it, so you can see the picture of what that looked like. There was a very nice setup with all the nice distancing for the COVID countermeasures. So everything was well taken care of, masks on, and well, I think it is a very good example of how hybrid conferences can be. So you were kind of with us, Dylan, there at the conference.
Oh, cool. I'm just a little more socially distant than everyone else. Like about, what, 1,500 kilometers by there.
Yeah, that's very safe, but we'll hope to have you here again next time.
I hope so. I can't wait to come back. So,
okay, I guess we'll wrap up here. Any questions that do arise, everyone, feel free to send them over in the Discord, and we'll have Irina join us here now. So give us a couple of seconds, and she'll do a bit of words as well.
all right. Thanks, everyone. Take it easy.